Hello, welcome to Engineers Mindset. So we are still on Gallilean Transformation equation. Let's consider the question on the board. A space bus conveying matriculating students of RIFSU traveling along the positive x-axis has a displacement of 6 km in 2 hours as it passes a traffic officer stationed at the matriculation arena in 0.00 hours. Half hours after the space bus passed the officer, he observed that a security dog is running at 500 meters in the same direction of the space bus. What are the coordinates of the traffic officer as measured by the running dog? Okay, so like I will always say, we always have two reference frames, okay, in Gallilean transformation equation. The first reference frame is always the reference frame of the observer, while the second is the reference frame where the event is taking place. So let's put down our first reference frame now. So we simply have this. This is Z, this is Y, and this is X. So it was stated clearly that the event is taking place in the X-axis, positive X-axis. So let's get down the second reference frame. We simply have, okay, this is simply Y prime, this is X prime, and this is simply Z prime. All right, so let's look at the equation again. A space bus conveying matriculating student of RIFSU traveling along the positive x-axis has a displacement of 6 kilometers in 2 hours. So displacement of 6 kilometers in 2 hours actually tells us what? Velocity of the space bus. Velocity is simply what? Displacement all over time, which means the velocity of the car is simply this displacement divided by the time in which this space bus is moving. So the velocity of the space bus, velocity of space bus, which is V, is actually displacement all over time, and that's simply equal to displacement is given as 6 kilometers. So we simply have 6, and kilo is simply by 10 to the power of 3 all over time. The time is 2 hours, so we convert 2 hours to seconds, which is simply 2 by 60 by 60. So we simply have this. This is actually 2 hours. Okay. And this is simply equal to 6 by 10 to the power of 3 divided by 2 by 60 should be 7,200. So we simply have 7,200. This is now in meters per second. So which means the velocity of the space bus is simply given us. So that simply gives us 0.83 meters per second. So this becomes the velocity of the space bus. All right, let's continue with the question. Question says half hour after the space bus passed the officer. So, okay, half hour after the space bus passed the officer, he observed. So, which means the officer is actually what? The observer. So, for the observing plane, which is the plane of the observer, this is actually the officer. So, the officer is actually the observer. Meanwhile, the space bus is actually what? The space bus is actually the second reference frame where this event is taking place. And the time which this officer observed is half hour. So time T is actually half hour, okay? And we simply convert this to seconds, it becomes half. An hour is simply 60 by 60 seconds. That gives us an hour. 60 by 60 seconds, which is 3,600 seconds. That's what makes up an hour. All right, so time which this observer or the officer observed this event is actually giving us 1,800 seconds. So we have 1,800 seconds. So this is the time which this officer observed that event. So half hours later, the space bus half hour after the space bus passed the officer, he observed that a security dog is running at 500 meters in the same direction of the space bus. So he observed that. So which means the officer is the observer. Now he observed is a security dog running at 500 meters in the same direction, not forgetting that the space bus is running at in the x-axis. The question says a space bus convey matriculating students of RIFSU traveling along the positive x direction. And then half hours later, the officer observed that a security dog running at 500 meters in the same direction. So the dog is also running in the same direction as simply what? In the x direction. And distance is simply what? 500 meters. So distance of the dog, okay, distance of dog or security dog, simply x is simply 500 meters. So this is the distance which the officer observed that dog. So let's simply always use this as our dog. So this is the dog and this is the space bus, while this is the reference frame of the officer. So if we trace an imaginary line here, let's now find the distance from the origin of the officer to the dog itself. This dog was observed in the x-axis or x direction, and that x is given as 500 meters. So distance from the officer, as can be seen here, is x. So from here to this point is actually what? X. From the officer to the dog is x. Okay, now distance from the space bus, which is the origin of the space bus now, to where this dog is taking place, we don't know it, so it's simply called x prime. So we simply call that x prime. Meanwhile, the distance from the officer or the origin of the officer to the origin of the space bus itself is given as a product of the velocity of the space bus times the time of the space bus. Okay, so we simply have vt. That gives us the distance of the space bus and the officer. Okay, the origin of the space bus and the officer. So we simply have this. So this is the whole information of the question given to us, can be presented as that. Okay. All right. So having known this now, recall we simply said this total distance from the origin of the officer to the space to the dog or the security dog is simply what? X, and it's simply the sum of the product of the velocity v and t plus this distance x prime, which is the distance of the officer, which is the distance of the space bus and the dog itself. So we simply have that x is equal to vt plus x prime. So we can now make x prime subject, which is the coordinate of the dog, and that's simply what? X minus vt. By simply sending vt over here, it becomes x minus vt. Okay, so x prime. So first of all, let's obtain vt. Vt is simply equal to, the velocity was given as 0.83 meters per second, and the time which this observer observed that motion was simply 1,800 seconds. So multiply by 1,800 seconds. Therefore, Vt is equal to, that gives us 1494 in meters. So this is now the distance of the origin of the vehicle to the origin of the officer or the observer itself. Therefore, the coordinate of the dog x prime is now equal to x, and x was given simply as 500 meters. So you simply have 500 minus 1494. This implies that x prime is equal to minus 994 in meters. Now, let's write out the coordinate of the officer itself. Let's get now the coordinate of the officer itself. So the officer, motion is in the x direction, and we obtain the distance in the x for the officer as simply what? 500 meters. So this is simply x, y, z, and t for the officer. So we'll put their values down. X is simply 500 meters. Y was not given to us in the question. So since it wasn't given, you simply take it as 0. Z was not given, so simply take it as 0. The time which this officer observed this motion was given as half hours, which we got as 1800 seconds. So simply 1800 seconds. This is the coordinate of the officer. Meanwhile, for the dog itself now, since y is not given, okay, for the dog itself, the coordinate of the dog, I always say, represents or remains x prime, y prime, z prime, and t prime. X prime we've obtained there. Y prime is simply the same thing as y. Since motion is not in the y-axis, therefore y prime remains the value of y in the first reference frame. Also, z prime is also what? Z prime. Also, z prime is also z, since motion is not on the z-axis. then z prime remains the same. T prime also remains the value of t. So which means from here, we can have that y prime is also y, z prime is also z, t prime is also what? T. So the coordinate of the dog as measured from the space box is simply given as x prime, and x prime gives us minus 1994 meters, and x prime gives us minus 994 meters. So simply minus 994 meters. Y prime is 0 because we don't have y prime. Y is 0 because y prime is equal to y. So simply 0. Z prime is also equal to z, and z here is 0, not given. So 0. And then t prime is also equal to t, and t is given as 1800 seconds. So this remains the coordinate of the dog as measured from the observer, and this is the coordinate of the observer, which is the officer, as measured from the dog. So you simply have these two coordinates. All right, guys, so I hope you find this video interesting. Please, if you do, don't forget to share your thoughts in the comment section, and of course, if you're new to the channel, please tap the subscribe button to keep getting updates on contents as this. I will see you in the next video with more and more questions on Gallilean transformation equation. In the meantime, stay safe and of course, cheers.